Maximum erasure value. You are given an array of positive integers nums and want to erase a subarray containing unique elements. The score you get by erasing the subarray is equal to the sum of its elements. Return the maximum score you can get by erasing exactly one subarray. An array B is called to be a subarray of A if it forms a contiguous subsequence of A. So basically, they're just telling us what a subarray is, but I think we already know that. Okay, so let's write out this problem. Yeah, why am I getting lag, bro? It's crazy. Lag on leetcode is crazy. Bro, I have a RTX 30 fucking 70, dude. What? Alright, we good? Alright, thank you. Okay. Um, so problem with subarrays you'd want to solve with the sliding window, right? So we want to do a sliding like window. So for a sliding window, we want to define our constraint. So our constraint here is a subarray with unique elements. Okay. We need unique elements, and what we want to return is the subarray with the greatest sum, basically. Because what they're telling us is return the maximum score, and score of a subarray is basically the sum of its elements. So subarray with the greatest sum. Just kind of add everything together. All right, so a good way we can solve this is by using a scene set, and also keeping track of all of the elements being added up just in a rolling sum. Okay, starting from the beginning, first we would put 4 inside of our scene set, and then we would add 4 to our rolling sum. And then we'd go to 2 and we'd say, okay, 2 is in our scene set now. And 4 plus 2 is 6. So now our total sum is 6. Moving forward, oh, well, we get to 4. Guess what? 4 is already inside of our set. Therefore, we're going to pretty much like cut off from the left. Okay, so in like a sliding window, right? So 4, we see we can't add another 4 to our set. We don't want to add another one. So we see that 4 is already in there. So we're going to start removing elements from the left until that 4 is gone. Okay, so once that 4 is gone, okay, it's literally the first one. And we're going to continue. 5, 6. Okay, you get the idea. Total, that's 17. And that's a valid window. Okay, that's how we're going to solve it. So, some things we can establish here. We can have left. We want a left here to keep track of all the elements on the left side. And we want a, I guess, cur to keep track of like the sum, kind of. And then we want like answer is equal to 0. Okay. And then we want a scene set on a set called scene. Okay. Yeah. Okay. So for right in nums, or we want to use a range because the numbers we're going to remove from the left, we're going to do it using nums, okay? Yeah. Okay. Okay, let's do this. So, first what we're going to do is cur plus equals to nums of whatever's that, right? And then scene dot add nums of whatever's that, right? Okay, but what we want to do first is we want to make sure that initially the first thing that we do is we're going to check to see what's in the scene set, okay? Yeah. Let's see. So, okay. Yeah. Okay, so while nums of whatever is at right is in scene, we're going to do scene dot remove nums of whatever is at the left side. Gonna move left forward 1. Okay. Gonna move left forward 1, and what we're also gonna do is, since we're keeping track of cur, we're gonna have to subtract from cur 2 of nums of whatever's at left. Okay. And here we're going to add cur right every time, add to the scene set every time, and then the end. Oh, okay. All right, yeah. And actually here we're gonna have like a greatest, or answer is equal to is the max, the answer, and cur. I'm gonna return answer. Okay, so this is a O of n runtime complexity, because we're just looping through the entirety of nums here. Yeah, because in this while loop, it's just we're pretty much only going to be only if the element is already in scene will we even enter this loop, which in the worst case, I guess in the worst case that could be every time, but this still isn't related directly to nums. So yeah, it's still not directly based off the inputs. It's still O of n, I believe. And then the set in the worst case scenario we could have like all unique elements, which would make our total like our extra space O of n as well in the worst case. Yeah. Okay, that's it. Thank you.